Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So, today we are going to cover chapter amino acids. So, there are not a lot of questions, just 7 questions for subjective and then a few more objective questions. So, I'm going to finish all the questions in one go. So, let's start with question number 1. The first one is it define alpha amino acids. So for alpha amino acid, this basically means our carboxyl group which is our COOH, and our amino group NH2 is bonded to the same carbon. Okay, so for example, like in question 1b, you see our COOH and NH2 bonded to this carbon, this CH. Okay, so kita kata kat situ. So question B, name the following alpha amino acid by using IUPAC nomenclature. So if I redraw the structure again, so NH2 bonded to CH, then bonded to COOH. Down here we have CH, and then we have CH3 and another CH3. Okay, so again for alpha amino acid, our carboxyl COH and our NH2 are bonded to the same carbon. Which carbon? This one in the middle, right? The numbering must start with carboxylic acid. That is our priority. So this is carbon number 1, number 2, number 3, and number 4. Therefore, at position number 2, we have one substituent, and position number 3, we have another. So the names will be 2-amino 3-methyl 4-carbon butanoic acid. Okay. Next question number 2. What we have here is NH2 single bond to CH, single bond to COOH. Then we have our CH2 bonded to benzene ring, C6H5. Okay. Carbon number 1 again still lagi carboxylic acid. So this carbon number 1, number 2, number 3. So this one is our substituent. So the name will be 2-amino 3-phenyl 3-carbon propanoic acid. Right. Next, number 3. We have our NH2 bonded to CH. Here we have COOH, and then CH2, and then OH. Right? This is carbon number 1, number 2, number 3. Number 2 we have amino, number 3 we have OH hydroxy. And the IUPAC names will be 2-amino 3 hydroxypropanoic acid. Okay, oops. And the last one is slightly longer. NH2 CH, then we have CH2 CH2 1CH2 and then COOH. Then down here we have another COOH. Okay, remember our alpha amino acid. So our COOH and NH2 must attach to the same carbon. So that is our alpha carbon lah. So numbering must start from this carbon. This carbon number 1, number 2, number 3, number 4, number 5. We have the same COOH group. So pentane dioic acid. And this is our substituent. Just one substituent. So the IUPAC name will be 2-amino pentane dioic acid. Okay, the dioic acid we don't have to put the numbering because carboxylic acid must be at the ends of the structure. Alright, so let's look at question number 2. They want us to draw the structure. Draw the structural formula of the following compounds. 2-amino 4-methyl pentanoic acid. Pentanoic acid. Okay, 2,4-amino pentanoic acid. So pentanoic acid meaning kita ada 5 carbon with carboxylic acid group. So 5 carbon carboxylic acid. So 1, 2, 3, 4, 5. So the number 5 should be carboxylic acid. Then this carbon number 1, carbon number 2 we have amino, so NH2. Settle. 1, 2, 3, 4. Number 4 we have methyl CH3. Right, so just fill in the rest of the hydrogen. So this one should be F1H. This one another 2H. One more. This one should be CH3. And carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. Alright, settle. Number 2 asks for 2-amino 3-hydroxybutanoic acid. So 4 carbon. C1, C2, C3, C4 must be carboxylic acid. So this is carbon number 1. Carbon number 2 must have NH2. Carbon number 3 we have OH. And make sure the carbon bonded to oxygen. Then we fill in the hydrogen. So 1 more H, this one more H, this one will be 3 more hydrogen. Okay. This is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4. 2-amino 3-hydroxy. Okay. So C, 2-amino 3-pentyl pentanoic acid. So 5 carbon. 1, 2, 3, 4, and number 5 is COOH. Carbon number 2 we have NH2. Carbon number 3 we have CH3. Yes, tak ada apa-apa. So fill in the hydrogen. 1 more hydrogen, 1 more hydrogen, 2 more hydrogen here. and 3 more here. Right, so COH carbon number 1, this is carbon number 2, this is carbon number 3, number 4, and the last one CH3 carbon number 5. 2 amino, 3 methyl. Okay. Next, question number 3. What is a zwitterion? Zwitterion. So, zwitterion is a molecule that has both parts of positive and negative charge. A molecule which has, right, number 1, one part positively charged group. Number 2, one part negatively charged group. Right? So, molekul ni dia ada dua-dua positive and negative charge. Ada sesuatu yang sama. But overall charge is equal to 0. Okay, so dia ada satu part positif lagi satu part negative charge, so plus minus cancel each other, kita dapat overall charge equal 0. Okay, so macam mana bentuk zwitterion ni atau zwitterion? Tengok pada structure soal nombor 3b. Draw the structure of zwitterion for glycine. So glycine is 2 amino ethanoic acid. Ethanoic acid meaning we have 2 carbon. Ethanoic acid, 2 carbon. The first one we have COOH. Alright, saya nak buat tepi dulu. Okay, dalam balik. So 2 amino ethanoic acid, COOH, carbon number 1, carbon number 2 we have amino, and H2. So this part we have hydrogen and hydrogen. Okay, this is glycine. So when we are going to form zwitterion of glycine, the carboxylic acid will lose its hydrogen, so ini akan hilang. So this hydrogen will be lost, dia akan transfer to nitrogen. Okay, macam mana dia buat? Okay, kalau saya nak buat, saya akan jadikan dia macam ni. Contoh, saya padamkan saya punya fish kat sini. Saya buat bonding. Double bond O, single bond O, single bond H. Tapi yang ni awak tak payah tunjuk lah. Saja saya ni sekadar nak tunjuk saja, tapi awak tak payah buat dalam exam. So lone pair of nitrogen, dia akan ambil H. Okay, so the bonding electron in between OH will return to oxygen. Okay, so what happened here is the final product will be, so this is our CH2, tak ada perubahan. Okay, since the nitrogen already take away this hydrogen, it will become NH3 and it will have a positively charge on that nitrogen. And then our carboxylic acid group will become COO. Since the electron from the bonding return to oxygen, so this oxygen will become O-. So So this is the zwitterion. Zwitterion of glycine. Okay, so we have one part positive NH3 part, and then we have one part negative COO part, but the overall charge is equal to 0. Next, question number 4. What is meant by isoelectronic point? So isoelectronic point, normally the shortcut we wrote this PI in the form of PI. So if you saw PI, okay, or if you come across PI in any of your lecture notes, reference book, or question paper, so PI is referring to isoelectronic point. Okay, so it's a pH. A pH where amino acids exist primarily as zwitterion. Dan nota. A pH where an amino acid exists primarily as zwitterion, tambah N its concentration is at maximum. Right. So dia adalah satu pH. PI itu adalah takat pH yang mana amino acid tu dia wujud majoriti sebagai zwitterion, dan concentration zwitterion tu adalah pada kadar yang maksimum, paling tinggi lah concentration tu. Right, so that is question number 4A. Number 4B, the isoelectronic point of valine is 2-amino 3-methyl butanoic acid is 6. Predict the structural formula of butanoic acid dulu. Kita buat COOH, nama kata 2-amino. So this one will have NH2, this one will have CH3. So we'll fill in the rest of the hydrogen, 1H, 1H here, 3 more here. So this is our valine. Predict the structural formula of valine at number 1, isoelectronic point. So kita akan ada plus and minus kat situ. So kita tulis balik. So CH3, CH, this one CH3, this one CH. Okay, the top one will be NH3 positive charge, and the COO will be COO minus lah. Right. Number 2, at pH 12, meaning pada keadaan base condition. So base condition bermaksud yang acid part akan bertindak balas. So yang mana acidic part, tengok pada structure yang tengah-tengah ni kita dah buat. Okay, so this is negative charge, so ini pada area base, akan jadi sedikit base. Positive charge kat sini, dia akan jadi bersifat acidic. So bila kita dalam keadaan basic, acidic part tu akan bertindak balas. So apa yang berubah? So if you look at the above structure, compare with the one that I am going to draw. This is CH. Okay, the top one, the NH3 part will now become NH2. The COO remain. Tak kacau. Okay, apa yang berlaku kat sini sebenarnya, okay, since this NH3 adalah acidic, so dia akan buang dia punya H, dan that H will bertindak balas dengan basic. Okay, saya ulang balik. Okay. Bila dia basic, maksud kita ada sangat banyak OH minus. Okay. So our valine pada isoelectric point, so dia CH3, CH, CH3, sini CH, dia daripada sini dia akan NH3, dia akan jadi NH2, COO ni maintain plus H plus. And then this H plus yang terkeluar daripada kita punya NH3 ni, okay, H plus akan react with OH minus pada basic condition. So dia akan jadi H2O. So dia macam meneutralkan balik the OH dalam basic condition tu. Tapi so yang tinggal inilah dia punya structure. Lebih kurang lah. Okay. Untuk acidic, so pada pH 1 kita pada acidic condition, ini kita ada sangat banyak H plus. So acid ataupun H plus ni dia akan bertindak balas pada base punya part yang ini. So the COO minus will receive the hydrogen from condition kita acidic, become COOH. So the structure will be CH3, CH, CH3, one CH. Okay. So refer balik pada gambar rajah yang asal, bukan yang pada gambar rajah isoelectric point. So the acidic part tak ubah, so macam lagi NH3. So up here will be NH3 positive, and this part will become COOH. Okay. So refer structure asal, then comparekan dengan yang baru. Okay. So compare between isoelectronic point, PI punya structure dengan acidic punya structure, and then PI punya structure with basic punya structure. Jangan ambil basic tukar jadi pH. Acidic. Tak boleh. Mesti comparison daripada PI, isoelectronic point. Right. Next, question number 5. The structural formula of tyrosine given here. Predict the structural formula of the product form when tyrosine reacts with NaOH. Okay. So the NaOH part will react with carboxylic acid group since dia adalah base, and juga dia akan react dengan phenol punya group. So, ini base. Ini base, ini kawasan acid, ini pun adalah acid, ini adalah base. Right. So dia punya structure dia akan jadi, this is our benzene ring, CH2, CH, NH2 tak kacau. Yang kita kacau adalah pada bahagian COO minus, ini masih ada O minus. Okay, ini yang asal. Okay. Yang baru masuk adalah Na plus daripada NaOH, Na plus daripada NaOH. Okay. Right. Settle untuk 5A. 5B, HCl. HCl ni adalah acidic. Bila dia acid, dia akan tindak balaskan dengan base. So kuasaan base kita kat sini hanyalah NH2. So dia akan tindak balas only with NH2. Okay, so structure dia akan jadi so OH ni tak kacau, CH2, CH, akan ni COOH tak kacau. Okay. So instead of NH2, dia akan jadi NH3 with positive charge. Ini kita akan ada Cl- lah. And the positive charge will be on nitrogen sebenarnya. So saya pasang balik ni, kita bawah sikit. NH3 positive charge pada nitrogen. Okay, so sebenarnya dia structure macam tu je lah. Dia macam tu je, NH3+. Dia dalam bentuk garam, salt. So sometimes you akan nampak dalam buku rujukan dia akan tulis Sebelah dia tu you can buat Cl minus. Alright. B. So methanol in the presence of concentrated sulfuric acid reflux. Okay. So alcohol in the presence of acid. So ini adalah proses esterification. Esterification. So dia akan bertindak balas dengan COOH pada kita punya carboxylic acid. Right? But since we have our concentrated acid pekat, so ini dia akan juga bagikan dia punya H nak balas with our base NH2. Okay. First, our benzene ring, phenol tak kacau, CH2, CH, right. Then we have our carboxylic acid group become ester. So OCH3. So this one come from this one lah, OCH3. Right? And then our NH2 will become NH3 with positive charge. Right. D. So D is a nitrous acid. So reaction with nitrous acid at 0 to 5 degrees Celsius. So you can tengok pada chapter amine. And if you look at our structure, we have primary amine sebenarnya. Primary aliphatic amine. Okay. So we look back at the original structure. NH2 is not attached to benzene ring. That's why it's aliphatic. And only have one carbon attached to nitrogen. Therefore, dia adalah primary. So, primary aliphatic amine. So, untuk primary aliphatic amine, kita akan dapat a mixture of product. The first one is alkene. And then we have alcohol. We also have haloalkane. And then we have nitrogen gas. Itu je fix. So, structure dia alkene. So, ini OH. Okay, single bond, our benzene ring. And then CH double bond CH. Atasnya adalah COOH. Okay, sini kita punya alkene. Next, kita juga akan ada alcohol. OH. Benzene ring. CH2. CH, OH, COOH, and then kita juga akan ada haloalkane, so OH, benzene ring, kemudian CH2, CH, Cl, so sini Cl, COOH. And the last one, we should have nitrogen gas. Okay, so ini tambah lah. Kita dapat mixture of product. Ada alkene, ada alcohol, ada haloalkane dengan nitrogen gas N2. Observation, kita akan nampak gas bubble produce. Right, so that is question number 5. Number 6. What is a peptide bond? Peptide bond is a bond ataupun a linkage, sambungan, linkage, bukan LING. Okay, link. It's a linkage between two amino acids. Since dia kata adalah peptide, peptide ni mesti daripada amide. Right, so yang kita nak cari adalah C double bond O, C double bond N. R, sini R lah. Right. So bond mana yang kita nak refer tu adalah bond ini. So this bond is known as a peptide bond ataupun a linkage between two amino acid. So ini akan jadi from the first amino acid this one apa ni, and this part from the second amino acid. Okay. Nanti kita tengok pada structure B. Dia kata right direction between phenylalanine and glycine to produce a dipeptide phenyl atau phenyl. Right. So dia minta kita bagi PHE atau phenylalanine and glycine. So kita akan kacau pada COOH untuk kita punya phenylalanine, kita punya glycine kita kacau pada amine NH2. So kita kena lukis dulu sebab depan ni adalah phenylalanine P. So kita kena lukis dia punya structure dulu. Untuk phenylalanine dia ada NH2, so kita kena kacau pada COH saja. Sini CH, sini akan jadi C double bond O. OH dia hilang. Dan sini ada CH2, down here we have the benzene ring. Okay. Dan kita draw dia punya peptide bond. So I use the blue color for peptide bond. And then kita draw kita punya glycine. So glycine kita kacau pada NH2. So NH2 will become NH only. One of the hydrogen is removed with the OH from carboxylic acid. This one is CH2 and then we have COOH. Right? And the blue color is our peptide bond. Sebab dia minta kita buat phenyl, so yang depan ni adalah structure from P, yang belakang adalah gly atau gly. Next, all amino acids are optically active, meaning contain chiral carbon. C star pula. Chiral carbon. Except for glycine, explain this statement by comparing glycine and serine. So glycine to amino ethanoic acid. So this carbon contain NH2, this one contain H, this one contain H, this one contain COOH. So this is glycine. Then serine 2 amino 3 hydroxy propanoic acid, 3 hydroxy. So OH, carbon ketiga CH2, carbon kedua kita ada CH and H2. This one COOH. This is serine. It's a sin pula. Serine. R-I-N-E. Okay. So untuk serine dengan glycine, kalau dikata chiral carbon, for chiral carbon it must have 4 different groups. Dash to 1 carbon. Okay. Masalah pada glycine adalah pada carbon yang ini kita ada NH2, COH dah dah. However, we have H dengan H pada carbon yang sama. So that's why dia tak boleh jadi optically active. So glycine they are no chiral carbon. Okay. Untuk serine however, okay, dia ada NH2 satu part, ni dia ada COOH another one part, we have H, one more part, and then CH2OH, 4. So dia ada 4 benda yang berlainan attached pada karbon tengah ni. Right. So this one is the middle, we known as chiral carbon. Therefore optically active. Okay. So, bila dia optically active, bermaksud dia boleh buat enantiomer. So hence question B, the stereoisomer of serine. Kita lukis dia punya stereoisomer. Enantiomer bermaksud lukisan dalam bentuk mirror image. So buat dalam bentuk tetrahedral. So atasnya adalah COOH. This one mungkin CH2OH. This one can write as NH2. Down here is H. And then our mirror image. Ini mesti bercermin garisan je. Okay. So carbon here, one there, one more here, and then one at the back. So here is COOH. Here we have CH2OH, and we have NH2. At the back we have hydrogen. Right, so settle question number B, 7B. Now let's look at the objective question. The general structural formula of amino acids is, kita tak letak alpha, dia kata amino acid dia, not alpha. So must contain COOH and NH2. Saya ada dulu ni. So ada NH2 saja salah. Ada OH, NH2, salah. Ada ni saja, salah. So kita ada COOH dengan NH2. Right, D. Dia mesti kena ada kedua-dua ni. Amino acid must contain carboxylic acid and amino group. Which of the following statement is true about amino ethanoic acid? 2 amino. So H2, this one contain NH2, this one contain COOH. Exhibit optical isomerism. Tak boleh sebab no ferrocarbon. Dah buat pada soalan nombor 7. Exist in anionic form in acidic. Kalau acidic donation, positive charge. So ini negative charge, so salah. Positif kena positif. So salah. Zwitterion in aqueous solution, betul. Soluble in non-polar, polar salah. Dia polar. Let's see. What species is produced when 2 amino propanoic acid dissolved in a pH of 2? So buat dulu dia punya zwitterion. So C with NH3 positive charge, and then COO minus 1, 2, 3. Dia kata pada pH 2 meaning keadaan acid ni ada banyak H. So, ia akan berubah, dia akan kacau pada CD. So, ini akan jadi tak ada lah. Right, so ini gambar dia. Oh, tu lebih carbon. Sorry. Eraser. Okay, carbon 1, carbon 2, carbon 3. So NH3 plus COOH. H3. Oh, sini ada lagi satu H. Tinggal. Macam D. Ada ni tak nak. Ini pun hilang. Ini pun hilang. Hilang. Lah. Lagi. Number 4. Identify the peptide bond. So ingat peptide bond tadi dia mesti pada C double bond O dengan N. So kita nak balik yang ni. So, peptide bond mesti yang ini, between C double bond O dengan N. Ini bukan, patutnya yang ini. Ini je. Ini bukan. Ini bukan. So B lah. Consider the following amino acid. So dia bagi ini PI025. Which of the following statements are true about the amino acid? Neutral negative charge pada neutral, salah. Cation positive charge pada acidic H+, betul. Zwitterion in the pH 9.74, betul. So 2 dan 3 saja betul. Ini salah. Number 6. Para amino benzoic acid. Okay, bla bla. This is PABA. Exists as a pair of optical isomer. Okay, salah sebab tak ada carrier carbon. Reacts with aqueous NaOH to form salt. So ini betul. Jadi NH2 benzene ring COO minus Na+. Right, betul. React with HCl to form a salt. Betul juga. Ini dia buat macam ni. Yang belakang tak ubah. Dia kembali NH3 positive charge pada nitrogen and then Cl minus. So 2 dengan 3. So lebih soalan habis tamat. Alright, so this is all for amino acids from subjective until the objective question. Okay, hopefully you can understand amino acid. Tak banyak pun sebenarnya, pendek, dan markah dia pun tak berapa nak banyak lah dalam exams. 7 je kot. Alright, so itu sahaja until the next chapter, which is the last one, polymer. Take care and Assalamualaikum. Salam sejahtera.